Hello students, in this video we're going to go over a couple examples on how to compute the determinant of a matrix. Now the determinant is simply an operation that you can perform on matrices. It has some geometric interpretation to it, which I'm not going to cover in this video. I'm just going to go through the rudiments of computing the determinant, but in a subsequent video I will go over the geometric interpretation of determinant. Right, so let's take a look at the first example here, and that is this 2 by 2 determinant. Now there's a couple different notations you'll see for determinant. You'll see det of a, or you'll see these absolute value bars around the a. I'll use in my videos either of those notations. I oftentimes just use the absolute value bars here, but note that this is not an absolute value. Okay, so the determinant, for example, of this matrix down here, this 3 by 3, is not all the entries, but just positive, okay? It's just a notation that it's used. So to compute the determinant of a 2 by 2 matrix, we're going to perform the following operation. It's going to look a bit like a dot product, but it's not quite that. What we're going to do is we're going to take 2 times 5, so we're going to go in a diagonal down this way, and then we're going to subtract when we go this way, 4 times 3. So some people visualize that as 2 times 5 in that direction, and that's positive. And then if you go in the other direction, 4 times 3, so down and to the left, so the left being the negative direction, you remember negative sign here, and you'd have 4 times 3. And then 2 times 5 is 10, 4 times 3 is 12, 10 minus 12 is minus 2. So you can see clearly that the determinant of a is not a positive number, it turns out to be a negative number. Now I'm going to show you a couple different strategies for computing the determinant of a 3 by 3. There is a third way to calculate the determinant of a 3 by 3 that I'm not going to cover in the video, and that requires you to rewrite the matrix and then multiply diagonals down and going the other way, and I'm not going to do that. I'm just going to use the cofactor expansion method here. It's going to look similar to what we did with the 2 by 2. So we're going to break this into a bunch of 2 by 2 determinants. So the first thing that we're going to keep in mind is this little mnemonic here. The plus and minus signs that are going to get associated with this determinant. Now the plus is going to start with this first entry here. Now remember, this is the entry 1, 1. If you add up 1 plus 1, you get a 2. That's an even number. That's a positive entry. This is the entry 1, 2. If you add up 1 plus 2, you get 3. 3 is an odd number. You get a negative. This entry here is the entry 1, 3. 1 plus 3 is 4. 4 is even. You get a positive number that gets associated with that entry. Likewise, this is the entry 2, 1, so 2 plus 1 is 3. You're going to get a negative number associated with that entry, and so on and so forth. So you get this checkerboard pattern with plus or minuses. That's important because when you calculate the determinant of a 3 by 3, what you're going to do is you're going to expand on one of the rows, one of the columns. You get to choose which one you want to do. Very common for people to pick the top row. You don't have to pick the top row. I'm just saying that it's very common to. So if I put 5, minus 2, and 3 down, then I look at my checkerboard pattern and I say, okay, since it's coming from the top row here, entries 1, 1, 1, 2, and 1, 3, I'm going to get a plus, a minus, and a plus in front of those entries. Then I'm going to compute some 2 by 2 determinants. Now notice that this 5 comes from this first column and this first row. So I'm going to ignore those, and I'm going to compute the 2 by 2 determinant of the remaining entries. So I'll get a 0, minus 3, 4, minus 3. Likewise, the minus 2 comes from this middle column, top row. That leaves the minus 2, minus 3, 0, minus 3 entries. So I will calculate that determinant. And then similarly, the minus 3 comes from the last column, the top row. So I'm left with minus 2, 0, 0, 4 for that determinant. That's the procedure for calculating a determinant. So again, if you're going to expand on the top row, you just write the top entries, look at your checkerboard pattern, it's plus, minus, plus, and then since 5 comes from this column, this row, I just look at the 2 by 2 determinant of everything else that is remaining if I were to cross out this top row and this top column. If I look at the minus 2, that's the middle column, top row, so I look at a little t there, and then I put the entries of everything else that's remaining, and then likewise for minus 3, I get rid of the column, get rid of the row, and I just put the matrix down there. All right, now you just compute these determinants. So 5 times, let's see, we got and remember, if you're going in this direction, that's going to be minus 3 times 4 is minus 12, but because you're going in the left direction, it's a positive 12. The minus 2 gives us a plus 2. Minus 2 times minus 3 is 6. That's a 0 in the left direction. Minus 2 times 4 is minus 8. We have a minus 3 there from that entry. You multiply and add up all those numbers, you get 96. All right, let me just show you that we get the same result if we were to expand upon, let's say, this middle row. Now, one advantage to expanding upon the middle row is that there's a 0 entry there, and that's going to cut down the amount of computations you have to perform. So what I'm going to do is I'm going to take the minus 2, the 0, and the minus 3. I'm going to write those down. Then I'm going to look at my checkerboard pattern for the second row, and that's a minus, plus, minus. So I'll put those signs down, and then I leave the bars for the subsequent 2 by 2 determinants. So if I'm expanding on minus 2, this row, where the minus 2 is, in this column, that means I'm left with minus 2, minus 3, 4, minus 3 for this determinant. Likewise, I'm expanding upon this middle, so I put up like a big plus sign, and I'm left with 5, minus 3, 0, minus 3. Although you could easily ignore this because you know it's going to be 0 anyways. And then if I'm expanding on this minus 3 here, then I put the minus 3 there. That minus sign, remember, comes from the checkerboard pattern. And then if I'm expanding on this minus 3, that's the third column and this middle row, so I'm going to have 5, minus 2, 0, 4. And then if you do all those computations, of course, you'll get 96 as well. So that's how you calculate 2 by 2 and 3 by 3 determinants. Okay, this is going to take a little bit of practice. So just remember the checkerboard pattern, remember to expand upon a certain row, and you should be in good shape. Okay, good luck.